Welcome to 1.4, Writing Equations and Inequalities. Like I mentioned in an earlier chapter, an equation is just an algebraic expression that involves needing an equal sign in it. In contrast, an inequality has that algebraic expression piece, but in this case, it's going to say that something is generally not equal. Something is greater than something else or less than something else. So inequalities will either have greater than or less than symbols, or you might have them be greater than or equal to with a bar underneath, or less than or equal to with a bar underneath. An open sentence, your book just defines as an equation or an inequality that contains an algebraic expression. So really, everything that we'll be working with equations and inequalities are all open sentences. That's really not a term that's going to come up a lot more, but in case your book spits it out at you, I wanted you to at least know what it is. Now, just like the last couple of chapters, we're going to have to work on paying attention to mathematical symbols and how that can be disguised in the English language. So when you see the equal sign, you might hear is equal to, or it could just be is. It might just be is by itself, or you might also hear the same as. This next one, when it's smaller on the left side and opens to the right, that means that the number on the left is going to be smaller than the thing on the right. So that means this is less than. Other things you might hear would just be like fewer than. The next one is the same as that, but now it's got the equal to bar underneath. So you might hear less than or equal to. Some other options you might hear is at most. So think about like if you're at a theme park and the kiddie rides, you can be at most this height in order to ride the ride, but you might be too tall, and at that point you can't ride it anymore, which means you have to be smaller than that. Or you might also hear no more than. The other direction is going to be greater than. You might also hear more than. More than. Finally, when there's the equal to bar underneath, you might hear greater than or equal to. Other options, you might hear at least. Again, back to the theme park option, you must be at least this tall to ride the ride. That would mean you could be that tall or taller. Or you might hear no less than as another option there. So now let's go and just break through a few sentences just piece by piece and see what they come up with. So the difference, again, when you hear difference, you want to look for the word and, because the word and is where the subtraction sign goes. In this case, our and is right here. So that means right here will be the subtraction part. And the stuff before the subtraction is twice a number k. Well, twice a number k just means 2 times k, or we can just write that as 2k minus 8. Is means equals 12. So that would be our equation, would just be 2k minus 8 equals 12. Our next option, the product of 6 and a number n, so 6 times n, because product means multiply, and again, and also shows up here telling us where our product sign would go. So they can be right next to each other, or you could put that dot in there. That would also be fine. Is at least. So that means we're going to have, it needs to be at least that much, but it could be more. So that means it has to be 6 times n has to be less than or equal to. Oh no, sorry. Not less than or equal to. That has to be greater than or equal to 24. I've flipped that up verbally, so let me come back and explain that quick. So the product of 6 and a number n is at least 24. So it has to be at least to the threshold of being 24, but it could be bigger than 24. That means 24 has to be on the smaller side, which is why this arrow part points to the 24, because the 24 is at the smaller side, but it can get bigger as it goes towards the 6n. Finally, a number y is no less than 5, so y has to be greater than or equal to 5, and no more than 13. So y also has to be less than 13. So it is also possible to have your variable or some portion of your inequality to be sandwiched between two different inequality signs, and that's totally acceptable as well. Next, we have to go and check to see if the answer of 3 is a solution to the following equations or inequalities. First, you have to define what is a solution. A solution is just an answer that works. So in this case, we're checking to see if 3 is an answer that works for our variable. So 8 minus 2 times 3 equals 2. Well, 2 times 3 is 6. 8 minus 6 is equal to 2, which does equal 2. So that works. Let's try it on the next one. See if 4 times 3 minus 5 equals 6. Well, 4 times 3 is 12. Minus 5 is 7. Does 7 equal 6? No. So that one does not work. The next one, let's try the 3 again. 2 times 3 is 6, plus 5 is 11. Is 11 greater than 12? No. 11 is smaller than 12, so the arrow would have to point in the other direction. And finally, 5 plus 3 times 3 is 9, plus 5 is 14. Is 14 less than or equal to 20? Yes, 14 is less than or equal to 20. So the next portion for us is we're going to look at trying to solve some things using just some mental math. So instead of actually trying to do steps, we're just going to think through and process out loud. So what number plus 4 gets us to 10? Well, that would be 6. 6 plus 4 is 10. So x has to be 6. 20 minus some number gets us down to 8. Well, what I would think is 20 minus 10 gets us down to 10 and has to be 2 more than that. So 20 minus 12 would have to get us to 8. 6 times some number gets us to 42. I always remember 6 times 6 is 36, and 42 is more than that, so it's probably going to be 1 more 6, so that's going to be 7. So n has to be 7. Finally, some number divided by 5 is going to get us to 9. Well, 10 divided by 5, 50 divided by 5 is 10, and that's just a bit more than 5, so you might then remember, oh yeah, 45 divided by 5 gets us back to 9. So A has to be 45. Now we're going to get into a couple word problems. So you're going mountain biking with some friends. You paid with a $10 off coupon for you and your 4 friends, and it was a total of $17 for you all to go mountain biking at the same place. The question then is, what is the regular price for the 4 of you? Well, one way you can do this is you can actually just write out an equation to see what happens. So some number minus our $10 off then gets us to that total of $17 that we paid. Well, we can then solve this, add 10 to both sides, and you'll come out with the regular price for 4 people is $27. Well, at that point, if we want to know how much each person would pay if it was a regular price thing, well, we then have to divide that 27 by 4, and that's going to come out to, I believe, let's see, 27 divided by 4. Actually, let me just do this on my calculator quick, because I don't want to tell you wrong. 27 divided by 4, 6.75. So our answer would come out to $6.75 each. However, when it was $17 for 4 people, we could also check and see that that would come out to $4.25 each. So having the coupon actually saved us some good money. The last question today. We've got a basketball player who scored 351 points last year. Will he score more this year if he averages 20 points per game for 18 games? So our question is, if we multiply 20 times 18, is that going to be greater than the 351 from last year? Well, if we do 20 times 18, that comes out to a total of 360 points, which is greater than 351. So the basketball player would score more this year. Well, that's it. So if you have any questions on this stuff, make sure you reach out, and otherwise, good luck.